Alright, hello everybody, this is Miss Summers with your notes today. Today is October 19th, 2020, and we are starting on Unit 5, which is water. Alright, so for this unit, I have done you the courtesy of providing a note outline. If you already have that printed off, that is fantastic. The outline is divided up by the slides, and each slide it has a question, and the information on the slide is what you're going to write, okay? I've highlighted the most important things in red. If you don't have an outline, it's okay. You can still do these notes just fine like we've been doing. All right, so let's look at this first slide, slide 1. Y'all know I love a good quote. Y'all know I'm all about those quotes. And talking about water, we have this quote from one of our founding fathers, Ben Franklin, and he said, "When the well is dry, we will learn the worth of water." When the well is dry, we learn the worth of water. So what is he trying to say there? He's basically saying that water is very important. We use water in a lot of different ways. And if we didn't have water, if that well does run dry, okay, our lives are going to be completely different, all right? We don't know what we got till it's gone. All right, so I want you to keep that in mind through this unit. We're going to talk about the water cycle today, and then over the next week or so, we're going to talk about like the structure of water, like rivers and groundwater and things like that. And then next week, we're going to jump into human impact. How do we affect water? Okay, so let's move on to slide 2. Slide 2 asks, where is most of the Earth's water located? So the majority of water on Earth, okay, 71% of the Earth is covered in water, but the majority of that is in the ocean. And ocean water, as you probably know, is salt water, and we can't use salt water. If you use salt water to try to like drink it and hydrate yourself, it actually does the opposite because there's so much salt content. Even though 3% of Earth's water is fresh, we can't use all the fresh water because 2/3 of it are frozen in ice caps and glaciers. Now, before you send me an email suggesting that we melt the ice caps and glaciers to solve the water crisis, I'm going to tell you that that would cause an even bigger problem. All right. So we actually end up with a very tiny itty bitty fraction of water that humans are able to use. Okay. Because most of it is in the ocean or in glaciers and ice caps. All right. Did you know, you don't need to write anything down on this slide, that there is the same water on Earth as there was when the Earth was formed over 4 billion years ago. The water that you're currently drinking from a faucet or from that water bottle that you bought contains molecules of waters that dinosaurs drank. Now, how is this possible? It's possible because water is recycled in the water cycle. And that's what we're going to look on for the next couple slides, all right? So, what powers the water cycle? The water cycle is powered by the sun. All right, so remember we talked about the sun's energy, how the sun's energy comes through fusion. Oh, look at me reviewing astronomy. Good job, Miss Summers. All right, that energy that travels to Earth provides the energy needed to make the water cycle happen. Okay, so we had this cutesy little diagram here. This is like a super simplified water cycle. But you see the sun carries the water up into the atmosphere, and then like a little water slide, they fall back down to Earth. All right? So the sun powers the water cycle. So what we're going to look at for the next slide, slides 6 through 12, we're going to look at the steps of the water cycle. And what I need you to write down, obviously I need you to write down the name. I'll need you to write down what's happening, the definition. And then I also want you to think about which sphere is interacting in that step. Okay, so obviously all of these are the hydrosphere because they all involve water. Okay, but some of these steps happen in the atmosphere. Some of these steps happen in the geosphere. Some of them happen in the biosphere. I want you to identify those. And then also draw a diagram for each step. So a quick diagram doesn't have to be, you don't have to be a Picasso or a Van Gogh or even a Rembrandt. All right, just a simple diagram so that you know, okay, during this step, water is moving upwards into the sky or down back to earth or whatevskis. Okay? So, first one, evaporation. So, give me a moment to write that down. Evaporation is the turning of liquid water into a gas. All right, so we have this diagram. I have the sun shining over the ocean. Water molecules are going to rise up into the atmosphere. Okay, so that's the sphere that's interacting here, the atmosphere. All right, so you've seen this on a hot summer's day. You spill a glass of water out on the deck or your front porch or whatever. Okay, over time, the heat from the sun is going to cause those liquid molecules to evaporate, turn into a water vapor. Okay? Our next step is condensation. I'll give you a minute to write that down. Condensation. So condensation is water turning from a gas into a liquid. So it's the opposite of evaporation. And when we're talking about the water cycle, this is how clouds are formed. Clouds are a result of condensation. That's condensation happening. So again, this step is in the atmosphere. And for your little diagram, you could draw a fluffy little cloud. That would be totally okay. That's what you need to know. All right, plugging on right along here. Precipitation, our third step. We're on slide 8 now. Precipitation is when water falls back to Earth. So it goes from the atmosphere back to the surface. All right, this can be in the form of rain, which we're most familiar with. Sometimes we get a little bit snow. Maybe we get some hail during a thunderstorm or sleet in the winter. Okay, as long as water is coming from the air back to the earth, that's precipitation. So you could draw some water droplets or a snowflake. Any of those would be really good diagrams for precipitation. Okay? So those 3 steps, evaporation, condensation, precipitation, I call that that's like the 3rd grade water cycle. That's what we learned like when we were real little youngins back in, 2nd or 3rd grade or whatever. All right, but we know, because we graduated elementary school and we went through middle school, we know that there's more steps than that. All right? So after precipitation happens, we might have runoff. Runoff is when water flows over the Earth's surface like we have in this picture. Okay, so this looks to be like a field of some variety, like they're planting something because they're in little rows. All right, it's rained. We've had precipitation. This water is on the surface and it's moving downhill. And you can see a little bit of erosion happening right here too. So runoff is water interacting with the geosphere. It's running over that geosphere surface. So for your diagram, you could draw a little river or a little waterfall, something like that. All right? So what about the water that doesn't run off? Okay, because obviously if every time it rained, all the rain became runoff, like we would be swimming all the time, there'd always be floods. Some of the water can infiltrate. We can have infiltration happen. So what I really want you to know, all right, and I think you might already know this step. This step might be new, it might not be, I'm not sure. All right, when something infiltrates, it enters something. So in this case, water is entering the soil from the surface. All right, so we have the water interacting with the geosphere. It's going into the geosphere. All right, we will talk about these 2 points starting tomorrow. We're going to talk about the difference between saturated soil and unsaturated soil. All right, if there's room in the soil for water to enter, infiltration happens. Okay, so for this diagram, you could have the ground and some little rain clouds over it, And you could have arrows going into the soil because infiltration is going into the soil. All right, our sixth step, I believe, we're on step number 6. Yes, we are. Percolation. All right. Percolation and infiltration are similar in that they both involve the geosphere. But percolation is the movement of water through the soil. So infiltration, it enters. Percolation, it moves through the soil. Okay, so we could draw the ground, and then you could draw some arrows going to the side. That would be representing percolation. So remember, infiltrating is entering, percolation is moving through. And that brings us to our last step. Okay, so we had evaporation, we had condensation, making a cloud. When it precipitates, the water either runs off like a river, or it can infiltrate into the ground and percolate. So how does it get back to the surface? Well, one of the ways is by transpiration. Give you a second to write that down. Transpiration. So transpiration is evaporation through plants. Water evaporates from plant leaves. Okay, so that water that's percolated through the soil gets taken up by a plant. The plant takes the water to the leaves because that's where photosynthesis happens. And that water is going to evaporate through the leaves, and it's going to go back into the atmosphere as water vapor. And from there, it can condense into a cloud and then precipitate, and the cycle starts all over again. All right, so for transpiration, definitely make sure you have like a leaf or a plant, maybe a tree or something, and you have little arrows leaving it. All right, in this step, water's interacting with the biosphere because plants are living things. It's also kind of interacting with the atmosphere because that's where the water ends up. So you kind of have a bunch of spheres interacting here, which is okay. All right, so those are our 7 main steps that I want you to know. There are technically more steps, okay, but those are the 7 that you should be able to put on a diagram for me, okay? So, the water cycle. Water is constantly being renewed. You don't need to write anything on this slide, okay? But you see your diagrams. You have your evaporation, your condensation, precipitation. Look, I have a river that's runoff. Infiltration is going into the ground. All right. The amount of water in this diagram is never, ever, 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 ever going to change. Amen. It's never going to change, okay? Because this is a recycling process, okay? After one process, it ends up somewhere else. It can move to another place, okay? Even like when an animal drinks water, that water is going to end up back in the atmosphere or back in the geosphere, or it's going to end up back somewhere, okay, from these processes. So, how do humans affect the water cycle? Actually, I lied. You did need to write something down on that slide. Does the amount of water on Earth ever change? The answer is no, it does not. So how do we affect it? So like, I've had children ask me, okay, Miss Summers, if the amount of water on Earth never changes, I don't need to worry about saving water or like conserving water, right? And the answer is wrong. It's true that we can never change the amount of water on Earth, but our actions can affect where it is. And remember from the very beginning of these notes, if water is in the ocean, we can't use it. Okay, it's there, but I can't use it for my own purposes. When we change our environment, like when we build things or change our landscapes, we can affect the water cycle. And I've given you a couple examples here I want you to write down. If we were to cut down trees to build a neighborhood or a store or for grazing land, for agriculture. By cutting down trees, that means there's going to be less transpiration. Okay, if there's less transpiration, that means there's going to be less water in the air. There's going to be less condensation. and less precipitation. All right, I didn't add those, but you see how I made a little, if this happens, then that's going to happen, then the next thing happens. Another example that I would like you to know, paving roads, okay? When we build a neighborhood, we're making roads where there used to be soil. Water can't infiltrate through pavement. It runs off. So we have less infiltration, less groundwater, more runoff, more flooding. Okay? So even though we're not changing the amount, we can still do things that cause a problem when it comes to the water cycle. Okay? So, those are our notes. Your last task for these notes, we have a pretty diagram right here. I know this is very fuzzy. It's a fuzzy-wuzzy diagram. But I want to see if you can identify the steps in the water cycle on this picture. Okay, so pause the video, take a moment, and unpause it when you're ready to check your answers. Okay, so you've checked you've used your notes, you've answered these. Let's double check these to make sure they're all correct. All right, step number 1, we have an ocean and then the water is moving to the atmosphere. That's evaporation. So 1 is evaporation. Number 2, I know it's very hard to read, but I promise you this says water vapor from plants. From plants. Anytime we have a plant, we know that's transpiration. So number 2 is transpiration. Number 3, we have a cloud. We know clouds form from condensation. So number 3 is condensation. Number 4, we have a cloud again, but here we have rain coming out of it, falling over the mountainscape. Number 4 is precipitation. Number 4 is precipitation. All right, and from there we have 2 ways that the water can go. Number 5, we see number 5 is in this river that's going back to the ocean. A river would be runoff. So number 5 is runoff. And that leaves number 6. Well, we have water going from the surface into the ground. That's infiltration. Number 6 is infiltration. You'll note the only step that's missing that we went over that's not on here is percolation. Percolation would be if arrows were moving side to side under the ground. That would be a way that we could represent percolation.